Evening. In computer design 21 CS 601, the computer design code, myself Sharmila, Assistant Professor, Department of Computer Science and Engineering, R.M.D.E. Engineering College. In today's video, we're going to discuss about the phases of compiler. Actually, there are totally 6 phases of compiler. The first one is lexical analyzer, second one is syntax analyzer, third one is semantic analyzer, fourth one is intermediate code generator, fifth one is code optimization, sixth one is code generator. Here, the input for this phases of compiler is source program. The output for the phases of compiler is target program. In between, the two things is happening is symbol table manager and error handler. The symbol table manager is used to store the symbols of the given program, and the error handler, which is used to check for the given program what are the different errors occurs while compiling that particular program from source language to target language. So we're going to discuss each and every phase. There are totally 6 phases of compiler. In that first phase is lexical analyzer. In that lexical analyzer, the input for the lexical analyzer is source program. The source program is nothing but the high-level language program given to the computer to read that program. The first phase, what it will do is, it collects all the sequence of character into a meaningful unit that is called as tokens. Each and every token is collected in the lexical analyzer. In that lexical analyzer, for example, token means identifier, operators, assignment operators, operands are collected separately. For example, in the given program, so high-level language program, A of index is equal to 4 plus 2. For that, A of index 4 plus 2, that A is called as identifier, A, the variable. And this open bracket is a symbol. It's called as left bracket. That index is called as identifier, the name given for the index by the programmer. This close bracket is a close right bracket. That equal to is again an assignment operator. That 4 is a number. Plus is a plus sign operator. 2 is a number. Like that, it will separate all the literals that is into a literal table, in the symbol table. That is meaningful unit called as tokens. Next phase of the compiler is syntax analysis. It determines the structure of the program, what particular syntax we have given, whether it is meaningful or not. For example, what example we have discussed with the lexical analyzer, the given line list A of index equal to 4 plus 2. The parse tree is generated here. For example, how the parse tree is generated, the 4 and 2 is added and stored in the A. That is happening. So it is whether meaningful syntax tree will form. That is called as syntax analysis. It determines the structure of the program. For example, the parse tree is given for the given expression A, index, that is open square bracket, index, close square bracket, equal to operator. We are adding 4 plus 2. So how we will draw a parse tree is the expression, that is assignment operator, equal to. Again, for the equal to, left hand side and right hand side. Left hand side is A of index. A is the identifier and open bracket, and then index is an expression, that is identifier, close bracket, the expression. Equal to expression is 4 plus 2. The 4 is again number. That expression number is the additive expression is added to the plus symbol. The expression, that number is 2. So 4 plus 2 is added, given to using the assignment operator given for the A of index. That is a parse tree drawn for the given expression. Next one is the syntax analyzer. We are drawing a syntax tree. How to draw a syntax tree? Same. A equal to index of, that is A is identifier, index is identifier, 4 is a number, 2 is a number. This is the syntax tree drawn for the given particular line. Next one is semantic analysis. That is the third phase of the compiler. The semantic analysis, a program, it's a meaningful, and whether it is a structure is a meaningful, whether the sum of its returning time behavior prior for the execution, static semantic declaration, and type checking, whether the given type of the particular data type is correct or not. Like that, we'll check each and every attribute, whether the given particular information by a semantic analyzer, whether it is valid or not for the particular data. That is a work done by a semantic analyzer. The syntax tree annotated with the attributes. That is the main purpose of semantic analyzer. In that annotated syntax tree, there we have given A is an array. And then identifier is a integer. That 4 number is a integer. Again, the 2 is a integer. Like that, each and every data type we are checking in the annotated syntax tree. Next one is the source code optimizer. The source code optimizer is nothing but optimization step. That is after semantic analyzer, we are optimizing a given code. Depends only on the source code. Separate phase is done here for the optimization to reduce the space, to reduce the cost. Like that, we're going to do the operation in the optimization. And then after optimization, that what we're going to do is we're going to create an intermediate code. What the intermediate code will do is it will convert after the 3 phases: lexical, syntax, semantic, analyzer phase. The intermediate code is generated. So what we are doing is t equal to, that is a of index 4 plus t. The temporary variable t is assigned to a of index t. What is t value? 4 plus 2 is 6. So 6 is stored in t. That is t equal to a of index. We can directly write it as a of index equal to 6. That is intermediate code is generated. That code sequence, how we going to write is move R0 comma index. The index value is moved to R0. Again, that R0, what it contains? 2. Next, R1, that is address of A, is contained R1. Then we are adding R1 comma R2. What is stored in R1? 4. What is stored in R0? 2. So 4 plus 2 is 6. So that 6 is stored in the R1, address of R1. Next is the target code optimization. We are converting this particular code into optimized code. The main purpose of optimization is address mode choosing, instruction replacing, and redundant elimination is the main purpose of code optimization. Then then the particular principle of data access communication among the phases are the token, that is each and every token, and the syntax tree is created. Then the symbol table. The purpose of symbol table is to store the identifier, variable, constant, data types. What are the different attributes available in the particular given source program? We are storing in the symbol table. Then intermediate code is generated. After the temporary file is stored as a bytecode. Then we are going to check whether it is logically structured, physically structured, sequencing the operation. The major impact of structure is reliability, efficiency, usefulness, and maintainability. The analysis and synthesis phase, we are converting the tokens into a synthesis phase and generating a tree structure and sending into a semantic by checking a type checking. Then we are converting into a front end and back end. That is, we are code optimization is done. Whether we going to optimize a code. After optimizing a code, we are passing the one pass compiler into one pass scanning and passing. Then semantic analysis is done. Then source level optimization is done in the semantic analysis. Finally, what we're going to do is we are going to check a error handling. In that error handling, whether it is static, that is compile time error, or it is a dynamic, or the exceptional error, like the different errors we are going to read in the further coming units. That we going to discuss in the error handling topic. Then that after the error handling, the phases of compiler, last phases, code generated, that assembly code is generated. After that, we're going to do people optimizing, that is a reduced code we're going to construct. In this phase of compiler, first phase is source program given for the lexical analyzer, that is given as a tokens. The token is given and then converted into a parse tree. The parse tree is converted into annotated parse tree. Then the intermediate code is generated, that is 3 address code. Then optimization is done and using then the 3 address code. Then the code generated, assembly code is generated. Then finally people optimization, the given code is optimized code is converted. So here we have discussed about different phases of compiler. Totally 6 phases are there in the phases of compiler: lexical analyzer, syntax analyzer, semantic analyzer, and intermediate code generator, code optimizer, code generator. These are the different 6 phases we are discussed in this video. Thank you.